Hi everyone, welcome to Numeric Learning. So in today's daily practice series of Do Math With Me, we have got 5 questions from the chapter Real Numbers and we will be solving them now. Okay, so please take your notebook and a pen and pause the video and do each of these problems. There are totally 6 problems. Let's do each of them together. Okay, so the first problem of the day is two numbers are in the ratio 2:3 and their LCM is 180. What is their HCF? So you are given two numbers. Let those two numbers be A and B. The ratio of the two numbers, that is A by B, is nothing but it's in the ratio of 2:3. So let the two numbers be, one let it be 2x and the other one let it be 3x, right? So if you're taking the prime factorization of 2x, right, you can write it as 2 multiplied by x, and 3x can be written as 3 multiplied by x. So in order to make these prime factors common, I will add a 3 to the power 0 here and a 2 to the power 0 for 3x. Now if you take, you are given, right? So the two numbers are in the ratio 2:3 and their LCM is 180. So let us find out the LCM first. So LCM will be nothing but you have to take the highest power of all the factors. So what is the highest power of 2? It is just 2. Highest power of 3, it's just 3. And the highest power of x is also x. So here you are getting 2 into 3, which is 6x. That's your LCM. And what is your HCF of this 2x and 3x? You have to take the lowest power. Okay, you have to take the lowest power of the common prime factors. So if you see for 2, the lowest power is 0. So I'm going to write 2 to the power 0. For 3 also, if you see, 3 to the power 1 and 3 to the power 0. So the lowest power is 3 to the power 0. And for x, it's x in both the places. So any number to the power 0 is 1. So 2 to the power 0 is 1, 3 to the power 0 is also 1. So what remains is only x. So the HCF is x. Now you are already given in the question that the LCM is 180. So let us equate it. So LCM, you are given LCM, that is 6x is nothing but 180. So x is nothing but 180 divided by 6. So 6 3s are 18 and 0. Therefore, your x is nothing but 30. And HCF is for these two numbers, if you see the HCF, that is x. Therefore, the HCF of these two numbers is also 30. Okay, that's your answer. Hope you understood. So these are the kinds of problems that you can expect. It could be any ratio, right? It could be 2:5. It could be, even if you are given HCF is given and you are asked LCM also, you have to follow the same pattern, right? You can pause the video and please try to do it yourself once. Okay, this is a very important question. Let's move on to the next. Yes. You are given, the question is, the LCM of two prime numbers P and Q is 221. Find the value of 3P minus Q. So whenever you are given LCM of two prime numbers, you should know that whenever you have any two prime numbers, the LCM is always the product of those two primes, that is P multiplied by Q. And you are given the LCM of the two prime numbers is 221. So P multiplied by Q is the LCM. Okay, so that is equal to 221. Now let us do the factorization, prime factorization of 221. If you see, you have 13, right? It starts with 13 and 13 ones are 13 and 7. 13 into 7 is 221. Okay, so P multiplied by Q is nothing but 13 multiplied by 17. These are the only two prime numbers. But you are given a condition. You are given that since P is greater than Q, which of the two numbers is a bigger number? That will be P. So therefore, your P is nothing but 17 and Q is the other number, that is 13. Now you can find out the value of 3P minus Q. So which is nothing but 3 multiplied by 17 minus 13. So what is 3 multiplied by 17? 51 minus 13. So if you calculate it, you will be getting 38 is the final answer. Okay, so this is also a very good question wherein you actually have to think, and what you have to know is this, that whenever you have any two prime numbers, okay, so for example the two prime numbers are 3 and 5 respectively, the LCM is going to be the product of them, that is 3 into 5, 15. Always remember it. LCM is always the product of, if you have the two numbers as prime numbers, the LCM is always the product. So this is done. Now let's move on to the third question. On a morning walk, 3 persons step out together and their steps measure 30 centimeter, 36 centimeter and 40 centimeter respectively. So what is given is, so you have a person walking, right? Okay, so suppose the measure of the steps, right? Each of these steps they measure, one is 30 centimeter, the other person's step measure is 36 centimeter and the third person's step measure is 40 centimeters. Okay, respectively. What is the minimum distance each should walk so that each can cover the same distance in complete steps? So what is that minimum distance that each one of them should walk so that each of them can they can cover the same, the distance covered should be the same, and all the three of them are taking equal complete steps. Complete steps means, suppose the distance is say 120. So 120 divided by 30 means 4 equal steps a person will be taking, and 3 equal steps the person C will be taking, right? Complete steps, 40 plus 40 plus 40 is 120. So it has to be complete. Now so in order to know this, what you have to think is, will the distance that is asked, right, the minimum distance that each one of them should walk so that they can cover the same distance, is that distance, can it be a lesser value? Can that distance be 10 centimeters or 5 centimeters? Is it logically, does it make sense to think that the minimum distance that each one of them should cover in complete steps is 5 centimeter? That's not possible. So whatever is the required answer, that required answer is definitely a greater value. So the required answer is much greater than the given data. And whenever you have your required answer is bigger than the given data, then it is an LCM problem. So you have to find the LCM of 30, 36 and 40. Let's do the prime factorization. So for 30, if you do, 30 is nothing but 6 5s are 30. So I'm going to write 2 into 3, which is 6, into 5. 36 I can write it as 4, 6. Yeah, I can write it as 2 square. Okay, 4 9s are 36. So 2 square multiplied by 3 square. So 9 4s are 36. Okay, and 40 I can write it as 2 square. So 40 I can write it as 8 into 5. So 2 cube multiplied by 5. Okay, 2 cube multiplied by 5. This is the prime factorization of the three numbers. Now tell me, what is the LCM? Before finding the LCM, let us make the factors common. So here I'll write a 5 to the power 0. Here I'll write 3 to the power 0. So for LCM, you have to take the highest power. Okay, for LCM, you have to take the highest power. Take the highest power of each of the common factors. So for 2, what is the highest power? Look at this. So 2 to the power 1, 2, 3. So the highest power is 2 cube. 2 to the power 3. For 3, what is the highest power? So here you have a 3 to the power 1, 2 and 0. So the highest power is 3 square. And for 5, the highest power is 5. So you're getting 8 multiplied by 9 multiplied by 5. Okay, so 8 5s are 40 multiplied by 9, 9 4s are 36 and a 0. So 360 centimeter is the minimum distance each one of them should walk. Okay, so 360 is that minimum distance that each one of them should walk so that they can cover this distance in complete steps. All the 3 people will be taking complete steps and they'll be able to cover this minimum distance. Okay, so I hope you understood. Please let me know in the comments if it is clear. And I hope you are pausing the video and please solve it. Mathematics is all about actually taking the pen and solving it together. The prime, may it be prime factorization or may it be this arithmetic that you're doing, all those calculations, multiplication, all these arithmetics, you should do it, right? Okay, so this is a word problem from LCM and HCF. Let us move on to the next question. 4 bells toll together at 9 a.m. They ring together at 9 a.m. They ring after. Toll means to ring after. So there are 4 alarm bells. Each bell rings after one is ringing after 7 seconds, one is ringing after 8 seconds, the other one is ringing after 11 seconds, and the 4th bell is ringing after 12 seconds respectively. How many times will they toll together again in 3 hours? So very easy. So there are 4 bells. Okay, so they start at 9 a.m. Okay, so the first bell rings after every 7 seconds. The second bell rings after every 8 seconds. The third bell it rings after 11 seconds, and the fourth bell rings after every 12 seconds. Okay, now after, so what you are asked is how many times will they now? So you have to find out how many times will they ring together. But before that, when will they ring together next, right? Will it be in 5 seconds or will it be a lesser time? No, it's not going to be a lesser time. The required answer, that is, when will all these 4 bells ring together the next time, right? After 9 a.m. So that time taken for all the 4 bells to ring together is definitely greater than the given data. So the required answer is greater than the given data. And whenever the required answer is greater than the given data, what hint you get is you have to calculate the LCM. If the required answer is less than the given data, then you have to go for HCF. So LCM of 7, 8, 11 and 12. Also remember these units of all these 4 values, right? It is the time taken for each bell and it is in seconds. So the answer that you will be getting will also be in seconds. So now let's do the prime factorization. For 7, it is a prime number, it is 7. For 8, it is 2 cube. For 11, 11 is a prime number, so it will be 11. For 12, 12 is nothing but 4 into 3. So 2 square multiplied by 3. Now let us make the powers equal. So 7 is not here, so I'll write a 7 to the power 0, 7 to the power 0 and 7 to the power 0. Here you don't have a 2 or 3 or 11. So 2 into 3 into 11. Here again I don't have a 3 or 11. Here also I don't have a 2 or a 3. And then here I don't have 11. So I've just made the prime factors equal across. Now for LCM you will be taking the highest power. So LCM is equal to, first tell me what is the highest power of 2 everywhere. So what is highest power of 2? It's 2 cube, right? 2 cube. Next, for 3, check the next one. So 3 to the power 0, 3 to the power 0, and then here it is a 3. So it's just 3. Now take for 7. What is the highest power of 7? It is just going to be 7. And for 11, it is again just 11. Okay, so now let's calculate. 2 cube is 8. 8 multiplied by 21 multiplied by 11. Okay, so here you have a 168 multiplied by 11. Okay, so if you multiply 168 and 11, so 8 10, 11, 12, 13, 14. 4, 1, 8. Okay, so you're getting 1848 seconds. The unit is very important. So all these 4 bells, they will toll or ring together after 1848 seconds, after 9 a.m. Okay, so now what they are asked is how many times will they ring together in 3 hours. First of all, this time is in hours. So let us convert it into seconds. Okay, so 3 hours will be equal to 3 multiplied by, let's convert it into minutes. 1 hour is equal to 60 minutes and 1 minute equal to 60 seconds. So this is your seconds. So 3, 6 are 18. 18 into 6. Okay, so you'll be getting 10800. Okay, 10,800 seconds are there in 3 hours. And the number of times these 4 bells will, the 4 bells will toll together in 3 hours of time will be, just divide them, right? So you get 108 divided by your 1848. Okay, so if you divide, approximately you'll be getting 5.844. So which will be 5 times. The answer is 5 times. Okay, because it's not yet 6. So the answer is 5 times they will ring. You can calculate it and see. Okay, so this is how you have to do such questions. These are also very, very important questions from word problems related to LCM and HCF. Okay, let's do the 5th problem. Please pause the video and make sure you are doing all of these steps. And if you have any doubts, please put that in the comments and I will definitely reply to you in the next video. Here is the last question for the day. You have to prove that root 2 plus root 3 the whole square is an irrational number. So let us prove that. And there's something missing here. You will already be given that, okay, given that root 6 is irrational. Okay, root 6 is irrational. Let's solve it now. So you have to use a contradiction method. So the very first thing is, let root 2 plus root 3 the whole square, let it be a rational number. Okay, so if it is rational means it can be written in the form of p by q. So root 2 plus root 3 the whole square is equal to, it is nothing but it's in the form of p by q, where p and q are integers. Where p and q are integers and q is not equal to 0. Now let us solve it. You don't have to do anything, just a plus b the whole square. A square, root 2 the whole square is 2 plus root 3 the whole square is 3 plus 2ab. So 2 into root 3 equal to p by q. Right? 2 plus 3 is 5. 5 plus 2, root 2 into root 3 is root 6 equal to p by q. Now what you have to do is just retain the term that contains the irrational part. You're already given that root 6 is irrational. Let 2 root 6 first be here. Okay, let it be on the left hand side. Take everything else to the right hand side. So p by q minus 5. Take the LCM, so you'll have q in the numerator, p minus 5q. Now what you can do is retain root 6 alone in the left hand side. Take 2 to the denominator. So p minus 5q divided by 2q. Now if you see, p is an integer, right? P is an integer. 5 and q, 5 multiplied by q are integers. 2q is an integer. So this is nothing but it's rational, right? Everything, whenever you have integer over integer or integer plus integer divided by integer minus integer, it's going to be a rational number. And root 6 is nothing but it is irrational. And irrational is not equal to rational. So what we can say is this makes our, therefore, this makes our assumption this makes our assumption wrong. What we assumed initially is wrong. That is, what did we assume? We assumed that root 2 plus root 3 the whole square is rational. Therefore, this makes our assumption wrong. Hence, therefore, root 2 plus root 3 the whole square is an irrational number. That's all. Hence proved. Okay, so there completes your answer. Now the same way, okay, let me repeat it again. So first of all, this is called a contradiction method. We will just assume that this is rational, that is equal to p by q. Open the bracket, solve it using a plus b the whole square. And then make sure you are retaining the term containing the irrational part on left hand side. Everything else take it to the right hand side, solve it, take the LCM, and then root 6 alone, that is the irrational term alone, keep it isolated and keep it in the left hand side. 2 you can take it to the denominator, so you have 2q. All these are integers. P and q are all integers. So integer over integer is nothing but it's a rational number. So irrational cannot be equal to rational, so this makes our assumption wrong. Therefore, the given number is an irrational number. This is how you will probably get a 3 marks for this question. Okay, this is the frequently asked question. Now, you can do this as your homework the same way. Prove that root 2 minus root 5 is an irrational number. Please do solve it and let me know in the comments if you are able to do it. And if you are not able to do it, please convey the same via comments, and I will definitely make sure in the next video of Do Math With Me, I will solve it and show it to you. I hope this series is being really helpful to all the students who are currently in class 10th. I look forward to a lot of your support, and it would really be helpful if you spend a few seconds of your time and write a small word, a few words in the comments as to how my videos are. Are you able to solve it or not? So hope to see all your comments, and I would definitely reply to each one of them. Till then, see you all in the next video. Happy learning. Please do share it with your friends and invite them to participate in Do Math with Numeriq Learning. Thank you.